energy is being transmitted from one place in a circuit to another. It's going from the power supply through wires to some kind of resistor, some kind of object or thing in the circuit that's going to get a response. And then it's got to close that loop and go back to the power supply. So what actually is in charge of transmitting electrons here, we refer to these as conductors. We know that conductors are, in fact, metal wires. Okay? Now, metal wires themselves, certain types of metal, super great at conducting. Copper, for the most part, is one of the best metallic conductors we have. Okay? And we use a lot of our electrical wiring is copper, or copper-based. Okay? It's not the only one, but it's quite common. Now, if you look on page 464, you're going to see that there's 3 little wires there that are surrounded by plastic. So when you look at those actual little ductile wires, okay, they're small little strands or filaments of wire that are usually twisted together to make a slightly thicker wire. Okay, every one of those little individual wires is moving electrons along. Okay, it's conductive. Now, if we just had metal wires going through our home, every time we turned a switch, every time we closed a switch and turned the circuit on, we'd run the risk of losing some of these electrons here, there, and everywhere. And if we lose those electrons in and around wood, what do you think would happen? Fire, smoke, okay? We don't want that. We don't want our homes to burn down. So these amazing conductors are insulated, okay? And we use basically plastic as an insulator. Plastic or rubber, most often plastic for these little wires. So again, on 464, if you look at these little bushels of wire, they're surrounded by little coating of plastic. And what that means is when we talk about actually insulating, okay, so when we talk about insulation here, okay, so if I've got my wire, okay, so I'm going to draw my little copper wires here, and if I've got my little bushels of wires, sometimes these wires actually fray, and there's little bits of them there. If we didn't have a plastic coating protecting that, we would lose bits of current here, there, and everywhere. We would lose electrical charge. Okay? So not only does insulation protect against, potential little fires here, there, and everywhere, but it actually ends up coating these wires. So if we do this and we've got a thicker coat, it forces all of the little wires to stay inside, even if they're frayed. So basically, we're not losing any of the charge. Okay? It maintains safety and efficiency. The last thing all circuits, and we're talking whether it's a complex circuit or a simple circuit, the last thing a lot of engineering or electrical engineering circuits have are safety measures. So that if the actual circuit does overload, okay, it's not going to create a spark and melt through the plastic that's insulating these wires and basically, set things on fire. All right? And these protection, these 2 types of protection, the 2 most common ones are fuses and breakers. In a home, you will have a breaker panel that's got a bunch of these switches. Okay? And if you live in an old home like I do, all right, and you plug a hairdryer in at the same time as the microwave, at the same time as a kettle, sometimes all the electricity just goes off. That is your house's way of saying, whoa, I'm overloaded. The circuitry is overloaded right now. I don't want anything to break, so I'm just going to shut it off. And I'm going to tell you to, that's going to tell you to unplug certain things. One of the most, and this one's a little bit more old school, is the formation of a fuse. Okay, some of you, especially if you live in older homes, okay, will have a fuse box where your stove is hooked up to a fuse. Your washer and dryer are. You've got fuses for the lights upstairs, downstairs, your furnace. And the inside of these fuses, okay, a fuse basically is a little cylinder. Okay, and they come in a variety of shapes. But basically, here's your circuit, and through the actual cylinder is a very thin little wire. Oftentimes, that wire is made of tungsten, which is a metal. But tungsten has a very low boiling point, a melting point, I should say, because it doesn't boil. Okay? It basically melts with very low amounts of energy compared to what copper would take. And the interesting thing here is that when there's too much energy going through this, it causes, okay, a break in the actual tungsten, and that breaks the circuit because the actual fuse here is embedded in the circuit as a fail-safe. If I get overworked, my tungsten's going to go. We're done, shut down. And it will only start working again when you replace the fuse with a new one. Because once this metal is melted, you can't put it back together again. Okay? The more common types of things nowadays are what we call breakers. And a breaker is basically like a switch. It operates in exactly the same way, but what you actually have here is you've got an attachment, okay, with a knob, okay, and when the knob is in place, your circuit basically goes around. Here's your light bulb, here's your power supply, and it goes through the breaker. And if that breaker is overloaded, what this will do is normally when the breaker is great, there you go, the switch is closed. It's going from metal here to metal here. But if that switch is overloaded, if that circuit is overloaded, the breaker acts as a switch. Undo. Okay, the breaker acts as a switch and then basically flicks itself open. So then what you have to do is you have to go to your breaker panel, flick the switch back over again. That's dealing with that part of the house specifically. You will basically have different breakers that are associated with different parts of your home and different appliances. Okay? And it will be labeled on your breaker panel. Our breaker panel is actually just in the hallway here, going into the girls' bathroom. That little kind of first little room. Okay, you'll see on the wall there's a breaker panel there. Okay? So the breaker switch is exactly that. It's a switch. And when it's overloaded, the switch is like, oh, I can't take any more. Flick, I'm going to open up. Shut the circuit down. Oh, okay, that means I got to go and unplug a couple things, because if you go and you flick the switch again and you don't remove anything, breaker's just going to go again. Okay? A roommate of mine used to straighten her hair for hours. Curly hair. Hours. It would take her 3 hours to straighten her hair. And I would wake up in the morning, and I have my tea every morning, and I would plug the kettle in, and one morning it just turned off, and I was ticked off. So I plugged it back in, didn't even go to the breaker switch. Or actually, I turned the breaker switch on, plugged it back in, she kept drying her hair, turned it off again, and I was just like, she yelled out something like, I'm drying my hair! And I was like, when are you going to be done? When it's dry. And so I had to wait till her hair was done, and then I plugged my kettle in, because otherwise it was overloading the system. And it will continue to overload the system until you remove something. Okay? So here we're talking about three big things. We're talking about conduction, which is wires. We're talking about insulation, which is coating around the wires to do two things. To protect, okay, against small little fires, and to maintain the intensity of the charge going through the wires. And then finally, we're talking about protection. Okay, and protection comes in the form of a fuse or a switch, a breaker, which will actually shut down the circuit without your control when the circuit feels that it is overloaded. Okay?